Hi everyone, welcome back. In this video, I'm going to show you how to graph polynomial functions in standard form. Okay, so this is a polynomial function you're going to use y equal x cubed plus 3x squared minus x minus 3. So the key feature are listed below. Okay, I'm going to add more as you continue. So the first one, you need to identify the degree. Okay, degree represents the highest exponent. So this polynomial function is already written in standard form. So it goes from a descending exponent on the variable x. So you have 3, 2, 1, and then 0. So the highest exponent is 3. And we know 3 is what kind of number? Okay, 3 is an odd number. So I'm going to write odd. Okay, so I only need to find out if the degree is odd or even. Okay, why? Because it allows us to describe the end behavior. Next, what is the sign of a leading coefficient? Okay, so the sign of a leading coefficient means identifying the leading term, the term with the highest exponent, which is x cubed. Okay, so now what is the sign in front of x cubed? We don't see any sign, right? So it cannot be negative. Yeah, so you don't see any negative, so it cannot be negative. Okay, if there's no sign, it means it's positive. Okay, so the leading term is positive. So I'm going to sketch a visual of the end behavior. So odd degree means, positive means the arrows on the right for odd degree point up, right? So if it's an odd degree, it means that the other arrows needs to point toward opposite direction. The opposite direction is going to be right here. So I have a visual of what it looks like, of the end behavior. Okay, so I'm going to look on the left and then on the right. So I'm going to write that as the x value approaches negative infinity, comma, the y value approaches, the arrow is pointing down, so I'm going to write negative infinity. Now, on the right side, so our x approaches positive infinity, comma, the y value is going to approaches, so the arrow is pointing up, so I'm going to use positive infinity. Again, what is a y-intercept? The y-intercept means, I didn't give you a graph. Okay, so I gave you a function instead. So how do we find the y-intercept? The y-intercept is going to be the number by itself, the constant here. And the constant or the number without the variable x is negative 3. So it's going to be 0, comma, negative 3. Or another way to find the y-intercept is to plug in 0 for x. Okay, so I'm going to use a template. And I plug in 0 for x. So everything cancels out except the constant, because the constant doesn't have a variable x next to it. Okay, so that's why the y-intercept is 0 equal negative 3. Remember, 0 comma negative 3. When we find the y-intercept is when x equals 0. Okay, so that's why I plug 0 into the polynomial function to evaluate, to find its output, which is negative 3. So now let's move on to the 0. So how do we find a 0? So to find a 0 here, you need to factor, okay, either by using the box method or by grouping. And I'm going to show you both methods. And remember, to find a 0 means, I know you remember, is this time the y-intercept means when x is 0, you're finding y. So now this time around, we want to get x, because 0 represents, the number name for x is mean x intercept, when the solution are real numbers, okay? So to find the x-intercept is when the y value is 0, the height is 0, okay? So how does it look like? So basically, you have y equal to x cubed plus 3x squared minus x minus 3. So the y needs to be equal to 0. So the new equation is going to be x. That's why I set up the y equal to 0. But I'm just going to consider this side. Okay, x cubed plus 3x squared minus x minus 3 equals 0. Then you're going to do the method by using the box method or by grouping. Okay, give me a few seconds. Okay, so now what I fit in the box, always on the top left, the leading term, always write the leading term on the top left. The bottom one is going to be always a constant. Okay, so those two needs to be always true. So to factor out, the first row, the greatest common factor between x cubed and 3x squared is going to be just x squared. Why? Because you have x squared and x cubed, and also x squared in 3x. Now the second row, the greatest common factor between those two terms, if you don't see any common factor, it's always going to be 1. So it's going to be negative 1. Okay. Now, vertically, if I look at the first column, the greatest common factor between those two, it cannot be x squared, right? It has to be just x. And then the second column is going to be 3. So let's multiply x squared times x cubed, x squared times 3x squared, negative 1 times x, negative 1 times 3, negative 3. Okay, everything works correctly. So the factor form is going to be x squared minus 1 times x plus 3 equal to 0. Okay, that's using the box method. Next, you're going to do by grouping. Okay, so by grouping means you're going to group the left two terms together, and then you're going to group the right two terms together. So make sure when you do by grouping, if you have a negative, the negative term goes inside the bound. The negative goes inside the parentheses. Okay, so you're going to factor the greatest common factor here, which is going to be on the left. The grouping on the left is going to be just x squared, and you're going to end up with x plus 3. And on the right, it's going to be negative 1, and you're going to end up with x plus 3. So again, you're going to factor the greatest common factor on the left, on the right, which is going to be x plus 3, the factor x plus 3. And then the leftover term is going to be x squared minus 1. Okay, so again, pick one method you feel comfortable using. Okay, so we are not factoring, but you don't factor using the grouping and the box method. Next, I hope you can see here, you recognize that you have a difference of 2 squared. And how would you do this? Okay, so I want you to remember to factor the difference of 2 squared is going to be what? X minus 1 times x plus 1. And then you're going to bring down the x plus 3, the factor x plus 3 equal to 0. Then you're going to apply the zero product property to each factor and set it equal to 0. And then solve for x. So x equal positive 1, x equal negative 1, and x equal negative 3. Okay, so now after doing this, we can find out, let's find the domain and the range. Okay, so now for the domain, okay, so you're going to, because it's a polynomial, and polynomial for the domain will be all real numbers, and I would like you to use the interval notation, like this. And the range, again, because we have an odd degree polynomial, the polynomial is odd degree, so the range is going to be all real numbers too, okay? Is it true for even degree polynomial? No, the range should be different for even degree polynomials. Okay, so we are done now. We can now start sketching. So I'm going to sketch a polynomial on my right here. Okay. So I'm going to label the x intercept, which is a -3, -1, and +1. Okay. Now after that, the y-intercept is at 0, -3. Remember, we found that to be 0, -3. So when x is 0, the y value is -3 right here. So I'm labeling the y-intercept. Now, the end behavior, we know this is odd degree. Remember, we know this is odd degree polynomial. And the end behavior, the visual looks like this. So what I'm going to do, I'm going to sketch something right here as a visual reminder. Okay, so I need to start, when I viewed the polynomial, I have to start from the bottom and make sure that because the root here are single, we have single roots, the polynomial is going to cross over at those single roots. Okay, so let's do that. And it should be done, right? And include the errors, that's it. Okay, now, so some of you may ask, okay, Miss Tonfack, how do we know how high to go? How high is going to be? We call that the relative extrema. Don't use vertex because it's not a parabola anymore. You can say relative extrema, and because or relative maximum here to be precise. But let me call it with relative extrema. So how do we find out the height of this relative extrema? So it gets for in this problem here, for this polynomial, to find how high to go, one way is to locate x equal -2, right? So the middle. So we know that the relative extremas occurs between the zeros, okay? So you're going to evaluate x of -2. So when x equals -2, what is its y value? So that's what you're going to do next. So to identify the y value, the height of this relative extrema between -3 and -1, which is -2, okay, I plug in x. I use a template, and wherever there is to be x, I plug in -2. Okay, so -2 cubed is going to be -8. Okay, negative 2 squared is going to be positive 4 times of 3 is positive 12. Negative times negative 2 is going to be positive 2 and minus 3. So when you combine those two, you end up with positive 3. And y negative 8 plus 12 is positive 4. Positive 4 plus 2 is 6. 6 minus 3 is 3. So when f is negative 2, x equal negative 2, okay, the y value is going to be 3. And 3 is right here. 1, 2, 3. So I was kind of close. So now to be exact, I can go back and erase and then put the dot here. Negative 2 comma 3 is right here. Then again, now sketch my polynomial. So now, so remember, what I want you to remember here is the relative extrema, okay, always occur between the zeros or the x-intercept, okay? So you have one relative extrema between those two x-intercept, which is negative 2 comma 3. The other one is between, and the other relative extrema is at negative 1, between negative 1 and positive 1, and it is 0 comma 3, 0 comma negative 3, sorry. Okay, so now, if it's in this case here, it was easier because the x here was an integer, okay? If it's not an integer, if you would, let's say the relative extrema was between negative 3 and negative 2, you have a relative extrema between those 2 points, you maybe want to take the middle, okay? Identify, take the average, okay? It should be here negative 2 point, okay, it should be negative 2.5. So if you have a relative extrema between those 2 points, you may want to use about negative 2.5 and find its corresponding y value. Okay, so that will be my insight to my advice. Okay, otherwise, if you want to find if it's more complicated, just do a guess. Okay, just sketch. Okay, something here between the zeros. But when you get to AP calculus, you take the first derivative to allocate the relative extremas. But for now, just evaluate, okay? Like I showed you here. If the number is not the integer, approximate, use the best, like the decimal, okay? So thank you for watching my video. I hope it was helpful, and have a wonderful day, and see you to the next one. Bye-bye.